me get out of here. Because now when I go to the table, it's pulling this equation. I don't want this equation, I want the fancy equation. So how do I pull over that fancy equation? How do I suck over the fancy equation? Bars. 5. EQ. Enter. So now when I do FG, when I do G, I suck over the fancy equation and I have this. That's, what does that represent? My observed or my predicted?
Observed.
This is my observed. I have my equation in, so now when I go to my table, I'm going to plug in those same values. 2, 3, 4, 6, and 7. Let's pretend like that's not there. This is going to be my predicted. When I subtract each one of those, that's going to give me my residual. So this one's going to be a negative 0.2558. That one's going to be a negative 0.2326. That one's going to be minus 5.2093. 6 minus 5.2093. And then we have alright, so we have 0.7907 and negative 0.14. What do we have to do to each one of those answers? Square them and then add them. Because we're doing the square, the sum of the squares. So I've got to square each one of those. And then I'm going to add them up. I'm going to try to do it all at once. Let's see how this goes. 0.2558 squared plus negative 0.2326 squared. We only have one more part after this. And 0.7907 squared plus negative 0.1628 squared plus negative 0.14 squared. Alright, so that should give me to how many places is the question? 3 places, so 791. This is when we pray that we did it right, 0.791. Last question. Comment on the fit of line in part B versus part D. So, I can probably look at it here better. So, look at part B versus part D. So, for this one, tell me about the fit of line. The line versus the dots. How many dots are on the line? 4 of the 5. Okay? And those dots are pretty good on that line. Now, if I come down here, 4 of the 5. But are the dots really good on that line? They're like a little bit below. So which line is all up in the Kool-Aid? Which one fits better? The first one or the second one? The first one. Because those dots were dead on that line. These are a little bit below. If you were trying to shoot a target, those were better on that line than the second one. So I would say, scroll back down, the line in part B, which is the top one, passes through most of the points. The line in part D minimizes the sums, which makes the best fitting line. When you're doing it in your calculator, y'all, your calculator is going to be more exact. Your calculator is, hold on, let me pull this up so that you can see. I've already got enough of it now. The main thing this problem is showing you is that even though your by hand may look prettier, your calculator is going to give you a better answer, is mainly what this is showing you. It is showing you that if you do it old school may look prettier. This is by hand. This was the y equals mx plus b where you found the slope and you did it by hand. It looks prettier. But when you do it in your calculator, it's going to give you the better answer overall. And you have 2 problems that are like this. Y'all, just get through the problems. It's not on the test, just get through the problems. Now, let me see if there was another one. There was 2 almost identical like that. That one.
I think it was number 5.
The other one. You want me to look at number 5?
I think that's the other one that's almost.
The other one like that is
Yeah.
number 5? Let's see. Is there another one in 4.2 you want me to look at? Get to your homework. Get 100 on your homework. And y'all, if you need to, I know sometimes they don't. When you go up here to view an example, sometimes they'll show you 400,000 without, without the calculator. They'll show you these long behind things. But most of the time, like all this crap, we don't do all of that. But sometimes you can get enough out of it, or shoot me a text message. Now, don't shoot me a text message at 11:45 saying, I need 15 problems done before midnight tonight. But if you shoot me a problem and say, I'm stuck on this one, I don't know what to do, I usually can work it out and send it to you before, in the next 5 minutes. The tutors have nobody over there, have had nobody over there. And even if they don't explain it the way that you want them to explain it, just get to your 100 for the homework. And make sure you know what you need to know for the test. All right, what else do we need to see for homework? Rachel, did that help?
Yeah, those are 2 ones I was looking at.
All right, what else? All right, Paige is here, Rachel's here, PJ's here, Miners is here, Travis has not made it, Josh is here, Nautica is here, Austin is here, DeQuasia's here. Okay, test is due Wednesday. Homework is due tonight. Some of us are really close to finishing. Some of us have a lot to be desired. Okay? 11:59 is when it's going to close. Today we are starting chapter 5. And just to pull up the next test, your next test is 25 questions. Your first test was 31, this test is 25. This test is going to be on chapter 5 and a couple of sections of chapter 6. So it's not on 4 chapters this time, it's just on 2 chapters, chapter 5 and chapter 6. So we're going to be talking about probability. I love probability. Absolutely love probability. When you hear probability, what do you think of? Fractions. What do y'all think of when you hear probability?
Marbles.
What did you say, Josh?
Well, marbles.
Marbles.
The chance of something.
The chance of something happening. Surprised I hadn't heard it yet. Gambling.
Poker.
Poker. Yeah. Percentages. You know, even weather. 30% chance of this happening. The chances. Okay. Probability is everywhere. The probability of an event is usually expressed as P of an event. So the probability that it rains, the probability that you're going to get pregnant, the probability that I'm going to gamble, the probability that I'm going to win. We always say probability of what's going to happen, okay? Probability is always between 0 and 1. You can't have a negative probability, okay? It's always going to be between 0 and 1 or 0 and 100% after you whoop it. So the probability of 0 means it's not going to happen. So the probability that it's going to snow in Florence today is 0. The probability that everybody came to stats class today is a 1. So the probability of a 1 means it's going to happen. So just to kind of give you an idea, 0 means it's not going to happen. The closer you are to 0, the more unlikely it's going to happen. A probability of a 0.5 means it's a 50-50 chance. And the closer you are to 1, the more likely it is to happen. And sometimes, you know, when you go take a test, you have a gut feeling of, you know, I have a 70% chance of passing this test. Or, I mean, you kind of know what your likelihood is, what your gut feeling is. So that's what we're going to be talking about today is probability, the chances, the likelihood. And it is going to be dealing with fractions. It is going to be dealing with percentages. But usually we start out as a decimal, 0 to 1. The probability. I look at everything in life as probability. I mean, when my child was little and we would go up in Justice or in a store and there's a bunch of hair bows and I'm like, what are the chances that she reaches in and grabs a pink one? I mean, probability is everywhere. I mean, I think about probability all the time, probably too much. I love probability. All right. Let's scroll down. To me, my definition of probability, what makes me happy over total. Every time I hear the word probability, I always say, what makes me happy over total. That's my definition of probability. What makes me happy over total. To be a probability model, all probabilities must be between 0 and 1, and all probabilities must add up to 1. So we can't have negative probabilities, we can't have probabilities that are over 1, and our probabilities have to add up to 1 or 100%. So you can't have a negative probability, you can't have a probability that's over 100%, and they all have to add up to 1. All right. And this is in 5.1, but I did put the problem up there, so if you want to use the book, fine. If you don't want to use the book, fine. In a probability model, the sum of the probabilities of all outcomes must equal 1. True or false? True. They all have to add up to 1, which is the same thing as 100%. Probability is a measure of a likelihood of a random phenomenon by chance behavior. True or false? True. Okay, that just kind of tells us what probability is. Move these up a little bit. For number 7, I gave you a probability model. We've been talking, and kind of it looks like a frequency table. Okay, where this is the column that's of what we're doing, and this is kind of like relative frequency, sort of. The probability that I'm going to choose red is 0.3. The probability that I'm going to choose green is 0.15. First of all, I want to know, is this a probability model? In order to be a probability model, all of these have to be between 0 and 1, and all of these have to add up to 1. So first we have to verify that it is a probability model. So my numbers have to be between 0 and 1? Are all of those numbers between 0 and 1? Check. Part 2 is they have to add up to 1. So if I add up all those numbers, does it equal 1? Check. So it is a probability model. Okay. What do we call the outcome blue? Tell me about blue in this problem. Are you ever going to see blue? No matter how many times I reach into that jar and grab a gumball, am I ever going to get a blue gumball? No matter how many times I reach into that gumball, am I ever going to see a blue gumball? We call that an impossible event. We will never see blue. It's just like me going to the gumball machine and wanting to get an M&M out. It ain't gonna happen. It's a gumball machine. Here, the probability of me getting a blue is 0. I'm not gonna see it. It's impossible. That is an impossible event. 0. Good? Remember, we always start out easy. All right, for this one, verify that it is a probability model. Are your numbers between 0 and 1?
Yes.
Do they add up to 1?
Yeah.
So yes, it is a probability model. If the model represents the colors of M&Ms in a bag of M&M chocolate, what does this model imply? Tell me about the bag of M&Ms. Describe them to me.
It's a bag of yellow and
They all yellow. Every M&M in that bag is going to be yellow. We can tell it by the probability model. They're all yellow. Yay? Why is the following not a probability model? Right there. No negatives. Why is the following not a probability model? If I add these up, 4, 5, 6, 7, 8, 9, 10, 11, 12, it equals 1.2 instead of 1. Which of the following numbers could be the probability of an event? Which ones could be the probability? Could 0 be the probability of an event?
yes.
Could 0.01? Yeah or no?
Yes.
3.5 or 0.35?
Yes.
Negative?
No.
1?
Yes.
1.4?
No.
So they have to be between 0 and 1. What about the next ones? Which ones can I get rid of?
1.5.
1.5? Any more?
That's the negative. No.
Nope, we're good.
That's it.
Suppose that you roll a die 100 times and you get 6 80 times. Based on these results, what is the estimated probability that the next roll results in a 6? Now, a die is 1 dice. Normally, y'all are used to hearing the word dice because in games, y'all play with 2 of these. But in math, we just use 1 of them sometimes. So a die is a fancy name for 1 dice. So if I take this die and I roll it 100 times and I get a 6 80 times, I want to know the probability of getting a 6. So I am asking you, what is the probability of getting a 6? So what makes me happy is if I get a 6. So on the previous page, I told you probability means what makes me happy over total. So how many total times did I roll the die? 100 times. And how many of those times made me happy? 80. So my answer is either going to be 8/10, which is 4/5. That would be the answer if they wanted a fraction. 0.8 would be the answer if they wanted a decimal. Or 80% would be the answer if they wanted a percentage. So 4/5, 0.8, or 80% is my probability. So what makes me happy over the total? Cool? Alright. Move these down a little bit. Alright, we have two sample spaces. A sample space means what's in there. It says let the sample space S be 1, 2, hold on, that's something else in there. Oh, let the sample space be the numbers 1 through 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Compute the probability of event F. So, I want to know the probability of F happening. So what's going to make me happy is if I see anything in F. So what makes me happy is an F. So if I walk into S's room and I see an F, okay? So what makes me happy is anything that is in F that is also in S. So how many things are going to make me happy? The 3, the 5, the 9, and the 10. So 4 things are going to make me happy out of a total of
10.
Which is going to be 2/5 or 0.4 or 40% according to how they want it. Yay? Now, we're doing another F. This time our F, what makes me happy, is an odd number. How many odd numbers are there? How many things are going to make me happy? Is 1 going to make me happy? Is 2 going to make me happy? 3,
Yes.
4, 5,
Yes.
6, 7,
Yes.
8, 9,
Yes.
10. So how many numbers made me happy? 5 out of, so what is my fractional probability?
1/2,
What is my decimal probability?
0.5,
What is my percentage probability?
50.
Cool. I'm gonna let you try 30 because 32 is tough. So just give me the decimal answer. We're not gonna interpret, we'll just do part A and part B.
You said the decimal?
Yeah, just give me the decimal. easy. The next two are kind of tough. Next one's tough, next one's easy, and the next one's tough. All right, anytime I hear probability, probability means what makes me happy. All right, we have 100 tulips, 40 of them are red, 35 are yellow, 25 are purple. What is the probability that a randomly selected tulip is red? So how many make me happy? How many make me happy?
40.
40 make me happy because I'm looking for red. And how many total are there?
100.
100. So what's my decimal answer going to be? 0.4. The next one, what's making me happy now, is purple. How many purples are there? 25, and the total is still 100. So my decimal is going to be 0.25. Easy breezy? Now, the next one you need to know about months. How many days are in a month? Now, this is where me and my husband fuss. When I was in school, I learned 30 days have September, April, June, and November. All the rest have 31 except for February. That's the time where February's days are 29. Anybody else learn that? I know. I don't know why. They're like, so he was taught January, February, March, April, May, June, July. Did y'all learn that?
Oh, yeah.
You didn't learn that either? You just Google it?
Yeah.
We have calendars and phones.
I know. So the way he was learned is you start on January. And so January is a knuckle. Knuckles have 31 days. So January is 31, and then February, if it's a valley, is a short month. So it has like 30 days or below. Then, so January, February, March has 31. April has less than 31. May has 31. June has less than 31. July has 31, and August has 31. So July and August are the only 2 months that have 31. September has less, October has 31, November has less, and December has 31. Okay? Because you can't Google if you have a month question on your test. And I guess nobody wants to learn my little jingle. I know. So, now we have, let's start one at a time. Determine the probability, so what makes me happy over total, that a randomly selected person has a birthday on the first day of a month.
You want decimal?
Let's just set it up. So what makes me happy over total? So I am happy if their birthday is the first day of a month. So give me an example of something that makes me happy.
December 1st.
December 1st, May 1st, January 1st, October 1st. So how many birthdays make me happy?
12.
12 birthdays make me happy. How many birthdays do I have to choose from?
365.
365. So October 1st, December 1st, January 1st, and I ended up writing it as 0329. I wrote it as a decimal. My math lab will tell you how they want it. The biggest thing is how do we set it up? Are we good with that one? I want you just to set it up. Don't say anything. Just set up the fraction.